This video is about sample selection bias. This example is somewhat similar to one of the missing data examples, but we'll talk about it in terms of sample selection bias. So imagine you have some individuals in the population, and the x variable on the horizontal axis that you want to look at is a binary variable that's equal to 1 if the animal has any white somewhere in it, and 0 if the animal does not have any white. I guess we'll ignore the little patch on the horse. And then the y variable on the vertical axis here is annual earnings. So imagine the animals have jobs and they make money. So here the turkey, it has x equals 0, so it doesn't have any white, and it has very high earnings, so it's high up here. These other birds up here also have very high earnings, so just in general birds tend to earn more money than these other animals down here who all make lower earnings. So in total there's 8 animals, there's 4 birds and 4 non-birds. If we were to just look at the overall mean, or sample mean, if we could observe everybody's earnings, the sample mean would be, somewhere in the middle here. And if we could, again, observe everybody's earnings and we ran a regression, you can sort of tell just visually the regression line would be something like this. Right? There's some observations below the line and some above the line, but it'll sort of go through most of the data there. So I'll have a positive slope, a positive relationship between the white parts and annual earnings. Since this is a sample selection bias example, of course, we will not observe all of these individuals. In particular, we sent out this earnings survey, but birds apparently are very private about their financial matters, and they did not even reply to the survey. So it's not like we have them in our data set and there's just some missing values. We just don't even have them in our data set. So you can think about how will that bias both the unconditional mean as well as a regression slope. So if we imagine the birds are not here, you can see overall the mean earnings is somewhere around this level. So it's much lower than if we could observe everybody, and it would be up here. And that's sort of intuitive, right? The birds are the ones who have the highest earnings. They're also the ones who are not appearing in our sample, and so we sort of observe overall lower earnings. We have this negative bias or downward bias. Second thing that's not as obvious is what is the effect on the regression slope. So recall, if we did observe everybody, we would have this positive slope here. If we don't observe the birds, though, those private creatures, then our regression just has these 4 observations at the bottom, and it'll be pretty flat, maybe even slightly a negative slope. So we'll also have a large negative or downward bias in the regression slope. It's not necessarily true that the unconditional mean and the slope bias will be in the same direction. That's just how this example happened to work out. But just to think through the intuition there a little bit, the issue is that we don't observe the birds, and they happen to be these sort of high earners, and there happen to be more birds as part of the x equals 1 group than part of the x equals 0 group. So if you remember that the regression slope with a binary x is just the conditional mean difference, when we only take out 1 out of 4 animals over here, that doesn't bias the mean difference, or conditional mean, sorry, as much as if we take out 3 out of the 4 animals. So when we take these out, we have a huge downward bias. When we take this one out, we just only have a slight downward bias. And so overall, we end up with this very negative bias, right? We should get that slope, but now we're getting that slope due to sample selection bias.